Every video game you ever play was built on one simple idea: storing and changing values. In this lesson, we're going to explore the foundation of all programming in C++, variable, data types, and constants. You'll learn how to create variables, understand what kinds of data they can store, and how constants protect your values from being accidentally changed. At the end of the video, I'll show you a short demo program that you can play with where you'll see these different data types in action: integers, floats, strings, booleans, and more. Remember, variables and constants are the beating heart of every game. They hold your player's health, their score, their ammo, even their name. Without them, your code can't remember a thing. Make sure to like, subscribe, and ring the bell so you don't miss future lessons. You can continue your path learning not only C++, but also Unreal, the most professional engine to create video games, and the strategies and methodology to build opportunities in the gaming industry. Leave a comment to tell me what you're learning, and support this channel and share this video with a friend who wants to start programming in C++ or creating video games. Alright, let's jump into a Visual Studio and start creating our first variables. To start this section, the first thing is opening the Visual Studio, and my goal is to create a new project that I will call Fundamentals. Select Console App, next, Fundamentals. Same address, and create. We're already used to this screen. I'm going to increase the size of the text by keeping the Control key down and using the wheel of the mouse. By this way, you can resize your text. You can also change the theme of your Visual Studio by going to Tools, selecting Theme, and let's say I want a dark theme. So this is how your Visual Studio will look. It is a matter of preferences. Let's try this theme by now. Now I want to remove all these comments as well as this line for the main function. The first thing we're going to cover are variable data types and constants. Imagine that you are designing an RPG. You need to store the hero's health, the name, and how much gold they are hoarding. That's where variables come. These are like little boxes in memory where you store information. The type of variables that you could have are first, the integers, whole numbers, perfect for hit points, ammo counts, or lives. The other are float and doubles. These are decimals like your character's speed or physics calculations. The character or car, which is a single character, like the first letter of a player's name. The string, which are whole words or sentences like Dragon Slayer 123. And booleans, which are true or false. We'll use this as a backbone of every game decision or every logic decision. And it's at some point you don't want something to change, like let's say the maximum health for a hero, then you use something called a constant. Write it once, lock it in, and you'll never have to worry about accidentally turning your hero into an immortal gold of 9 million HP. But that's enough of a theory. Let's show this in code. The first thing I want to add is an include for string. This will allow me to use strings inside my code, as you can imagine. To begin, let's add a comment to present integers, which are whole numbers. An example, as I mentioned, was integer health, which could be 100. Integer ammo for another character or for the same character, which will be, let's say, 30. Now let's find the floating points, which are decimals. An example, a float speed equals to 4.5 f. This is the way of creating the notation. We can include a point, and at the end we have to include an f, saying that this type is a float. The other will be the double, let's say accuracy, and this will be 99.9. In that case, we don't need to add the f. The question might be, what is the difference between a float and a double? That's all about precision. What I mean is how many decimal places your number can keep without losing accuracy. Think of a float as a small water bottle. It holds a decent amount, but there is a limit. A double is a big water bottle. It can store more decimal places, so your numbers are more precise. In technical terms, a float usually takes 4 bytes of memory, while double takes 8 bytes. That means doubles are more accurate but also take more space. So when do you use which? If you're doing simple things like character speed, jump height, or camera rotation, float is more than enough. But if you're doing scientific calculations, physics simulations, or anything that needs high precision, double is a safer choice. In game development, we usually stick with floats because performance matters more than microscopic precision. And hey, if your player moves at 4.50000001 instead of 4.50000002, nobody's going to notice. By the way, if your goal is not just to learn C++, but actually build a career in video games, I'd like to invite you to check out the Game Creator Accelerator mentorship. Because here's the truth, learning the technical side like C++ and Unreal Engine is only half of the journey. The other 50% is about strategy, having the right plan, methodology, and the mindset to move forward one step at a time, even after your daily job. Inside the mentorship, I work one-on-one with creators like you to help them build a steady path into the industry, not rushing, not burning out, but growing with consistency and clarity. So if you ever dream of turning your passion for games into something real, visit booleans.com to learn more or reach out to me directly for a one-on-one session. Links in the description. The next type is the characters, which are a single symbol. The definition is char, let's say grade, equals A. It is key to mention that you have to use single quotes. On the other side, we have these strings, which are text. We declare it as a string, let's say player name, equal to Dragon Slayer 123. You can see that we have an error here, which is identifier string is undefined. This is because for me to use a string, I need to add the namespace standard. Now there is no error. Now there is another approach. Instead of having to write this line of code every time, is to add the namespace before calling the function. At the top, after the includes, I will use using namespace standard or std. Now I can remove this and there is no error anymore. The next type of variables are booleans, true or false. To declare it is pretty simple. Bool, let's say, is alive equals true. You can also use 1 or 0. And then we have the constants, values that never change. The declaration starts with const, then with the type, let's say integer, and let's call this one max health equals to 100. Now we know that this value will never change, different to the rest of them. How we can transform anything into a constant is just by adding the const before the type of the variable. Now let me use the cout that we learned in the previous lesson to present all these values. And finally, because this is an integer main, I can also add the return 0 and save. What we're doing in these expressions is just using these variables to present them when we run the program. The first line that will be presented start with a player, then we link after this a string, the player name, which is defined here, and then we made a jump of line. We said this is the end of line, I want to go to the next one. For the health, we have something similar, but we also added in the middle this slash to separate the health and the max health. With the ammo, just presented the ammo. With the speed, just the same thing. With accuracy, we added after the accuracy this percentage, which is another string. And the grade, we add the grade, and is alive the boolean. Now let's run. And here you have the information. Player, Dragon Slayer 123, health 100 of 100, because the initial health was 100 and the max health is 100. Ammo 30, speed up 4.5, which was this one, accuracy 99%. I think I can add in the accuracy a colon here. The grade A, and it's alive because we said that it is true. The compiler will process it as a 1. If it will be false, of course, will be 0. Now you know how to create variables, understand the different data types, and how to use constants to protect important values in your code. These may seem like small steps, but they are actually the foundation of everything you'll ever build in C++. Every health bar, every player score, every ammo counter, all of it starts with what we just learned today. In the next lesson, we'll take this a step further and bring your code to life with operators, the tools that make your program think, calculate, and react. Make sure to like, subscribe, and ring the bell so you don't miss the next part of this series. And if you know someone who wants to learn programming or start a career in games, share this video with them. It might be exactly what they need to get started. And remember, if you want to go beyond tutorials and start building your path into the gaming industry, check out the Game Creator Accelerator at booleans.com, where I help creators like you combine technical skills with the right strategies to build a steady, long-term career in a video games industry, all after office hours. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. See you soon, my fellow creators.